All right, today we're going to take a look at section 1.7. We've talked about equations, both linear and absolute value equations, and we're going to look at inequalities today. And there are some similarities between those. So some of the things you're going to do today are going to be like, I thought I already did this, and you did. And then some of the things are going to be a little bit different. So what are inequalities? What do we mean by that?
Isn't that the lines for when we graph?
We will be graphing them, at least thinking about them in terms of graphs.
Less than, equal to.
Yeah, so inequalities include less than and greater than, and sometimes they have the equal to bar underneath. What does equations mean? You got it, say it.
It equals something.
It equals something. It means it's got an equal sign in it, okay? So equations have the equal sign, inequalities have the less than or the greater than, less than or equal to, greater than or equal to. So that's the primary difference. Like I said, there's some pieces of that we solve the same way, and there's some that we solve differently. So to start with, we're going to do some intervals. Okay, so intervals, and the way we express them, there's more than one way. The first column in this table is the set notation, like what it looks like in set notation. The middle column is what it looks like in interval notation. And then the right-hand column is what Anna said we would be doing today, and she was right, is we're going to look at how it looks like on a graph. So the first set notation, this says x is greater than or equal to a. Okay, that's the greater than symbol. An interval for that actually starts with the value a. I'll use black. Starts with the value a, and it continues on forever. So what we say is that goes to the value infinity. Infinity, of course, is not a value, it's a concept, but it means that it continues forever. Now you'll notice in the interval notation on the second line that there's some parentheses. Intervals that have an infinity part on them always have a parenthesis. So the part where we have infinity will always end or begin with a parenthesis, okay? Whether we have a parenthesis or a bracket will depend on whether or not we can equal the value. If we can equal the value, we have a bracket. So we're going to have a bracket that this begins with. If we didn't have that equal to sign on the bottom of the inequality, we would have a parenthesis there. And then when we do a graph, one of the things to be aware of first is that your graph needs to have arrows on the end, because the arrows indicate that it continues in those directions, continues forever, or continues in those directions. Depending on the resources that you use, the books that you see and so forth, sometimes they're very specific in what they include on the graph and so forth. For our purposes, we just need to make sure that if we have a portion in the interval that's a number, like in this case the a, that a is included on our graph, okay? So it doesn't necessarily have to include the number 0 or anything like that, but it does have to have an a on the graph because a is a value in our interval. So we need to make sure a is represented. And then the cool thing about the interval notation that our textbook uses, and that's becoming more and more common in most textbooks these days, is that this interval notation here that's in the middle and this graph use the same symbols. So for example, since we used a bracket right here, we're going to place a bracket at A, and it'll open in the same direction. This bracket is opening toward the right-hand side, so our bracket on our graph is going to open toward the right-hand side, so it looks like this.
So we'll be drawing a bracket on the number line?
You have a bracket on the number line, exactly. And then you actually, again, because the interval says that you're going to go past the bracket to the right, your graph goes past the bracket to the right. And you draw an arrow to indicate that it continues going in that direction. I'm trying to use purple so you can see it distinguishably different from the black. Maybe I should have chosen a different color, but does everybody see that okay? Tim?
So if it was just greater than, would it just be a regular parentheses?
Yes, it would. So, and we'll see that happen down here where we have this parenthesis, and instead on our number line, we'll have a parenthesis on our number line.
Also, is there a time when there's two brackets?
Yes, there would be, and we'll have an example of that in our lesson today. Yes. Good questions, guys. Okay, so this line right here indicates one way that these could look. In our second line, what you see filled in is you see the middle piece filled in. And so we're going to go backwards and fill in the first column with the set notation. So you'll notice on this one that negative infinity comes first. So first of all, notice that it's negative. So if it's on the left-hand side, it's negative infinity. If it's on the right-hand side, it's positive infinity, okay? Negative and positive side of a number line. In addition, you'll notice that there is a parenthesis beside A, right? So are these the values that are representing values that are bigger than A or smaller than A? Smaller than A. And the reason we know that is because A is the ending point, and it is the infinity part comes before it. So these are the values that come before the value for A. So when we're expressing this, these are values that are less than A. And it's strictly less than. There's no equal sign, and how do I know?
No bracket.
There's no bracket. I have a parenthesis beside the A instead of a bracket. Now, in terms of the graph for this, or the number line, and those are sort of interchangeable in this particular context. Again, I need to make sure that A is represented on my graph because A is on the interval that I'm looking at. And I need the values that start at negative infinity. In fact, they start on the left-hand side, far left-hand side of the graph. So let me change the color just for, to change here. Let's use red. So we're getting all of these values over here before A. At the value of A, will I have a parenthesis or a bracket? A parenthesis. Will the parenthesis open to the left or will it open towards the right? The left. And the reason it will open toward the left, a couple of ways you can remember, is number one, it has to look just like the parenthesis that's already here, right? So the parentheses go the same direction. Or you can actually think about it going towards the shading that we just did. Okay, the parenthesis has to open, or the bracket has to open towards the shading. And this graph is incomplete so far. We do need to make sure that we draw an arrow indicating that it continues towards the left, in this case forever.
Professor,
Yes?
why is it we're drawing brackets, just not a dot?
Dots and okay, so a couple of things about that, Anna. Some books will use dots and like closed dots and open dots. Do you guys remember closed dots and open dots from a math class before? Okay, great. And then some books use the parentheses and the brackets. They're just different notations for the same thing, so that's the first thing. And our book is using the parentheses and the brackets, so that's what we're doing. The other thing is that you see more and more the curriculum moving toward that. You see more and more the parentheses and brackets being used more, and the dots and open dots being used less. So that's what we're seeing happen in our...
It's the same concept?
Mhm. Exactly. So open circles are equivalent to parentheses, and closed-in circles are equivalent to brackets. Yeah, but it's the same thing. It's just a different way of notating the same thing. I'm kind of a fan of this notation because it mirrors exactly what the interval is, and I kind of like that. And so me personally, I like the idea of using the brackets and the parentheses on the number line because they actually have this very natural feel coming from the interval notation. All right, the last one here actually hits on Tim's question. Do you notice that this one does not continue to the right or to the left forever on this graph? Okay, so this notation, again, this is why I like it. Actually, if I look at the graph notation, I can fill in the interval notation almost immediately. It starts at A, it ends at B. So the two interval end points over here are A and B. There's a parenthesis at A, so there will be a parenthesis before A. And then there's a bracket at B, so there will be a bracket after B. And that's super friendly because it looks just like the other column, right? It really does. Now, in terms of the set notation for that, the set notation or the interval set notation starts with A and it ends with B, just like the others. And the values that we are allowed to have are in between them. So the X shows up in between the A and the B. Because we have a parenthesis by A, we will have a symbol here at the beginning that does not have a line underneath it between A and X. And you'll notice this says that the A value is smaller than X. And that's exactly what we mean. We mean that all the values are actually going to be after the value of A. A is the smallest it can be. And then between the X and the B, we've got this bracket over here to end at the B. we're going to have a less than or equal to symbol. Okay, we get the equals because it's a bracket. And again, B is sort of the ending point. All of our values are supposed to be before the value of B. They're less than B. Now, the interval is always written sort of from left to right the way that you would read a number line or read English. So that's how our interval or our set notation is actually written as well. Okay, everybody good with that? All right, so what we're going to do is we're going to have an example where we're going to express it in all the notations. Now, obviously, they're going to give it to you in one notation, and you're going to express it in the other two. So the directions simply just say express in all three forms, but you actually just have two answers because one of the forms is the form given. So the first one is which form? Is it set, is it interval, or is it graphing?
Set.
It's set. You can express either form next. I'm kind of a fan of drawing it on the graph first because I think visually. So that's the notation that I'm sort of inclined toward to move toward first. I mentioned before that the value that they give you, in this case radical 3, is really the only value that I need represented on the number line for the purposes that we're looking at today. And then this says that x is greater than or equal to 3. Which side will we go away from on the 3? Will we go towards the right or will we go towards the left? Towards the right, because those are the values that are greater than 3. Let's go with that one. Yep, Jeremy.
My freshman teacher, I mean, we did this my freshman year, and like I hated them. But
Okay.
the greater than or less than or greater than, the arrow points in either direction. Does that show where the arrow is going always, or does that? I mean, because that's how he kind of told us to.
You have to be careful because the interval or the set notation that they gave us, x is greater than or equal to 3, also could be written, square root of 3 is less than or equal to x. And if you think about it like what you just described, now you're in a quandary because you don't know which way to shade if you're simply looking at where does the arrow point. Because this is actually equivalent notation. These are equal.
Yeah.
Do you see what I'm saying?
Yeah,
That's
I
a
was
problem.
just wondering because that's how he kind of said,
Yeah,
well,
that's how I would-
if the arrow points this way, then it's probably going to go that way.
Yeah,
But I just.
and again, it will if you make sure that your x is on a specific side of the inequality in all cases. But you can't guarantee that it's always going to be given in that form, because it would be just as valid for me to give you the question in the second form, and then you're going to end up probably shading the wrong direction if that's the case.
Okay.
Does that make sense?
Yeah.
So you have to be a little bit careful. Are they normally given in the form that we started out with it? Yeah, it is normally given that way, but does it have to be? It really doesn't have to be. So there's kind of a concern that I have a little bit with just looking at the direction of the arrow when that's the case. Okay. Another way that you can think about it, sometimes as you'll hear people talk about that the sign will be opening towards the bigger side, right? So this is saying that the X is bigger because it's, I don't know, have you ever heard of it being a Pac-Man? I know Pac-Man's before your time, but you guys know what Pac-Man is? Okay, that's good. Just checking. One of these days I'm going to ask it in class and everybody's going to look at me and go like, Pac-Man, what the heck are you talking about? Okay, so we have this symbol, right? You see Pac-Man? You can see Pac-Man now, right? So Pac-Man is going to be eating, if you will, the bigger value. So the bigger value in this case is X, and the smaller value is the square root of 3. So we're shading to the right-hand side because it is the bigger value. So on my number line, it's over here. And then the question is, do I use, and I use that arrow at the end of that, of course, do I use a parenthesis or a bracket opening in that direction? Bracket, how come, Rebecca? Yeah, this part, that was so not visible. Let me try that again with a white. Because of the or equal to in the bottom, right? That part right there tells me it's going to be a bracket. So on my number line over here, I will have a bracket right there. So this would be my shading for this. I think when you do it in my math lab, it'll probably turn it into a red color or a blue color or something, so you'll be able to see it very clearly. As long as you just are very clear in how you're writing it. You don't have to necessarily use a different color on your work when you're turning it in, but you're welcome to if you'd like to have a separate pen or pencil that's a different color, that's fine. All right, so this is one of the two extra forms. It's the graphing form, but I also need the interval notation form. But again, like I had told you on the previous slide when we were talking about it, I like this graph because it lends itself very well into the other form. So I have a bracket, and the bracket is opening to the right, so I need a bracket that opens to the right. This goes on forever, which means that we'll have a parenthesis at the end of it, because that can tells you that you can't equal what comes next. I have a square root of 3 is where it begins, and because it doesn't end, I will have an infinity at the end. Does that make sense?
I like this one a lot more than the circles.
Do you?
I like it a lot more.
The circles stuff was stuff that we did when I know that's how I learned it as well. And once I got into teaching was when I started seeing other resources that were moving toward this direction. And we've seen a trend in that over the last, I don't know, I guess I've been teaching almost 20 years now. So I know, it's crazy since you can tell I'm only like 28 years old, right? Yeah, I've been teaching since I was 8. So it's cool. All right, let's take a look at number 2. Number 2, a graph. Can you guys draw a graph for me? Graph what you think it should look like, and then we'll confirm that you have an adequate picture. Okay, so just draw what you believe it should be. If you make a mistake, if you're using pencil, you can erase it. If not, you can scratch it out. So it's totally fine. If you make a mistake, just do what you think it looks or should look like. And then once you're done with what you believe your graph should look like, write the interval notation you believe it should have. All right, now everybody's sitting sort of close enough to somebody that you can look on your partner's paper and see if you got the same thing. Okay, so look across the aisle, look behind you, check with somebody that's sitting nearby, and see if you have the same thing written for your graph and the same thing written for your interval. If you don't, see if you can figure out which one of you maybe has a mistake or was thinking backwards or whatever.
Did you just confirm your own answer?
Okay, so your graph should have had a 54 on it, did it? Fantastic. Your graph should have been shaded to the left. Wonderful. As you shaded to the left, hopefully you remembered you need an arrow in that direction. Did you remember that? Good. And then at the 54, did you use a parenthesis or bracket? Parenthesis, fantastic. Did it open to the left or to the right? To the left. Sounds like you guys all did it right. Wonderfully, wonderfully done. Good job. Andrea's clapping for us all. That's so good. I appreciate that. That's wonderful. Yes, good job. And then, did you write an interval?
Yes.
We did. Good. Does your interval start with a parenthesis?
No, we
Oh, we were given an interval. We need set notation. Sorry. When I zoom in and out on my screen, I forget where I was. It started with an interval. Okay, interval. Usually, kind of like when Jeremy was asking, like, or at least it was related to his question, usually you do see the X written first. You don't have to, but most of you probably did that. And you had a 54. And the question is, what symbol goes between them? So was it a less than symbol, or was it a greater than symbol? A less than. And another mnemonic device that people will sometimes remember is less than is to the left. They're both L's. Less than, left. Got that? Less than to the left. It's a nice handle. Do I put equals underneath it? No, why not? Because there's parentheses and not brackets. All right, everybody good with that one? Okay, moving on from there, then what we're going to be doing is we're actually going to be looking at equations that we're going, not equations, I said that wrong, my apologies. Inequalities that we're going to have to solve now. So far we were just looking at ways of expressing them, and now we're going to look at how we solve them. So the solving process for inequalities is much the same. What do you suppose you do first on this particular problem? Subtract a 1 is exactly right. So I have 2x on the left, the same symbol is between them, and I have a 5 on the right. Then what do I do? I divide by 2. The x is now on the left, and I have a 5 halves on the right. And I have solved the inequality. This is the solution. So I've done half of what the directions said. The other half said that I'm supposed to, that was bad. I should not cover up the word graph when I box it in. Graph! Okay, so on a graph, I've got my number line graph with my arrows at the end and a 5/2 marked, right? Will I be shading to the left or to the right of the 5/2? To the left, because it says left and less than, right? And then I will be putting an arrow. Will I use a parenthesis or a bracket at the 5/2? Parenthesis, will it open left or right? Left. Now, this directions didn't actually ask us how we wanted the answer to be written. So if it doesn't ask, you're done at this point. If it did ask for the interval notation, what would it look like? Negative infinity. And then what?
5/2 on the other side.
A 5/2 on the other side. Keep going, Deja, you're doing great.
And then parentheses around it.
Parentheses around both ends, right? Very good. Okay. Yes, thank you, Holly. Yes, thank you, Deja. That was great. Okay, everybody good with that?
I
Okay.
have a question.
Hannah.
Would we not flip the sign around?
We'll talk about when we flip it around. So right now the answer is no. We haven't changed the direction of the sign. But I think the next one we will. So we'll look at it. Okay. So take a look at this one. First of all, it's got a fraction in it. So that makes it a little bit different automatically. And we'll encounter something midway through that will also change things up a little bit. So in solving this, what would you like to do first? Get rid of the fraction by multiplying by the 7, and I agree, that's what I would like to do as well. So if I multiply by 7 on the left and on the right, I will have no more fractions. I have a 5 minus 3x on the left. I still have the same sign between, and I'll have a 14 on the right. All right, what's next? Subtract a 5, I agree. Okay, I have negative 3x on the left, and I have 14 minus 5. What is that? 9 on the right. All right. Here's where the change happens. We need to divide by negative 3, agreed? Okay. Divide by negative 3. And 9 divided by negative 3 is negative 3, and I've got an x on the left. And I'm going to tell you what we're going to do, and then I'm going to justify why it's true, okay? What we're going to do is we're going to change the direction of the inequality, which is what Anna had asked about. Instead of it being greater than or equal to, it's going to become less than or equal to. So that's the what. Let me talk to you then about the why. Let's say, for instance, that we started with this negative 3x, and we have the greater than or equal to 9, and our goal was to simply move things around so there were no negative 3x's. I could do that, right? I could add the 3x to the other side. So now I have 0 over here. I have 9 plus 3x. And I could subtract the 9 to the other side, right? So this is negative 9. This is just an avoidance of the division by negatives, basically. And then I could divide by 3. And what I'd like for you to recognize then is that, again, this kind of goes back to the question that Gracelyn and Jeremy were looking at originally, right? Is that when I do that, I've got the negative 3, and it's greater than or equal to x. I mean, like, that's what I would get by doing that. And if I took that inequality and I turned it around, this is the one I would have, isn't it? It really is. So that's what's happening, is that I'm avoiding moving things around a whole bunch of times to avoid, the negative business. Because what really happens is when I divide or multiply by a negative, the direction of the inequality will change. Okay, so you don't have to, I'm not going to ask you on the test, why does this work? But I do want you to know there is a real reason. It's not just like hocus pocus kind of stuff, okay? It really has a reason behind it, and that's a one way to justify what's going on, okay? All right, so we've solved the inequality. It's x less than or equal to negative 3. We at least need to graph. We don't know if we need to give an interval notation. We will in a minute just for fun. So here's my number line. What value do I need to put on the number line? Whoops. A negative 3. Which direction will I shade, left or right? Left. With an arrow at the end. Will I use a bracket or a parenthesis on this one? A bracket, because it says less than or equal to. So this is my graph. If I were writing the interval notation for this, I'd start with a parenthesis, negative infinity to negative 3, and then I'd actually have a bracket on this one, right? Okay, everybody good with that? Okay, so the only difference in solving inequalities as opposed to equations is that when I multiply or divide by a negative, I change the direction of the sign. See, you don't have to worry about that with an equation because an equation has what kind of a sign? An equal sign, and an equal sign doesn't have a direction, right? It's sort of direction independent. It's equal, so I don't have to do anything with that, but an inequality does. Here's a different kind of one. This one has an and information in between it. We're going to solve both of them, and then we're going to compare what we have. Okay, so we're solving both of them just like the other problems we had. We're going to subtract the 5. Got negative x is less than, what's 4 minus 5? Negative 1, and then I divide by my negative 1. So this becomes x is greater than, I changed the sign, good job Selena, greater than, in this case, 1. So this is part of my answer. The other half, I'm going to add a 5. 0.2x is less than 6. And then what am I going to do? Divide by 0.2. What would x be? Or what would the value be? 6 divided by 0.2. 3? 30. There we go. And which symbol will I have between them? The less than symbol. This one didn't change because there weren't any negatives I multiplied or divided by, right? Okay, so don't get carried away and just flip inequalities all the time. That doesn't happen. It's just when we multiply or divide by a negative. So these are my two inequalities that I have, and I have this word and occurring in between them. So what does it mean? Well, it means it has to solve both of them together, right? It has to satisfy both inequalities. I need to be both greater than 1 and less than 30. Yes, Jeremy?
We would not flip the sign on that one.
Mm-hmm. On this one?
Yeah, can you explain that? Because I did the same thing because we just divided by it.
But what did we divide by? We didn't divide by a negative, right? We divided by a positive.
Gotcha.
So it's only when we divide by negatives that we flip signs. Good clarifications. Okay, so I need a value that is both greater than 1 and less than 30. Can you give me just one number that satisfies that condition?
2.
6, 2. How about 28? 28. Okay, so these are numbers in this case, which are sandwiched in between, right? So in terms of my number line, it looks like that third example that we had way back at the beginning. I'm going to have two numbers on the number line, a 1 and a 30, and I need to shade in between them because this says and. I need both of those statements to be true at the same time. And then I look at the individual values. So here's the number 1. Will it have a parenthesis or bracket? Parenthesis, and it needs to open toward the shading. So the parenthesis looks like this. And then this 30, will it have a parenthesis or bracket? Parenthesis, because it doesn't have the line, right? And it will open again toward the shading, so it's going to open to the left. And if I were looking for an interval notation for this one, it looks almost like an ordered pair, right? Like an XY ordered pair. This is one of those terrible conventions in mathematics where something looks like it could be two different things. It's just the context you're working in. This is an interval from 1 to 30, not including the numbers 1 and 30. Okay, similar problem, has a different word in between. What word do you see on this one? Or, and it will make a difference. We solve the same way though, okay? So we're going to solve the process the same way. On the left one, what are we going to do first? Multiply by 2 is a good start. Okay, so that eliminates the denominator, giving me a 4 minus x. Sign stays the same. 1 times 2 is 2. Then what? Not divide by 4. Careful. Subtract the 4, because it's added and subtracted, right? It's not multiplied. So we'll subtract the 4. I get negative x on the left. Don't forget the negative that's still with that x. And what do I get on the right? Negative 2. And then divide by negative 1. So this is x.
And flip the sign.
And then flip the sign. Good job. So I flipped my sign, and negative 2 divided by negative 1 is 2. 2 over 1, which is 2, right? Okay, so I'm half done. Stop right there on that one. Over here on the right-hand side, what am I going to do? Multiply by negative 3. What did I multiply by? Good. It was a negative, so this is where I'm going to flip my sign on this one. The flipping the sign doesn't have to happen always at the end. It happens anytime we multiply or divide by negative, and that's right now. So this symbol changed to a greater than at this moment.
So if you miss it with that one, can you recover
If you go back and you check a solution, like in the interval you're looking at, kind of like I said, what numbers would work? You know what I mean? And we were like 2 and 6 and 28. And you went back and looked, does that number actually work in both inequalities? You could catch it that way too. Yeah. On the left-hand side, it eliminated the fraction, which was the goal. So I just have the 2x minus 7. On the right-hand side, I have 1 times negative 3, which is negative 3. Then what? Going to add my 7. 2x on the left. Symbol stays the same. Negative 3 plus 7 is 4. And then divide by 2. Am I going to change this inequality? No, because it's positive. What if I had another negative here? Could I change the inequality a second time in the same problem? Sure could, because I'm still multiplying or dividing by a negative. I don't here, but it's still a possibility, right? Here's an x. It's greater than, and then 4 divided by 2 is 2. So these are the 2 points we're here. And this word in between says or. This says x is less than 2 or x is greater than 2. It sounds a little bit funny because why? It's everything but 2. Good job, Grayson. It's everything but 2. Can I draw that on a number line? Well, of course I can. I would draw a number line. The only number that I actually am going to put on my number line is 2 because it's the only one showing up in either inequality. On the first inequality, it says less than 2, which is shading to the left with an arrow. On the second inequality, it says greater than 2, which is shading to the right with an arrow. And because it says or, I'm allowed to be in either of those places. But where am I not allowed to be?
2.
At 2. So my interval needs to have those parentheses present at 2. Does it look a little weird? Yeah, it looks a little bit weird. But it's correct. Any value but 2 in this case is correct. If I were looking at the interval for this, it would be negative infinity to 2. And I would have 2 to infinity, like this. In between these two, what you do is you put a U. A U means union. It just means joining them together, kind of like, you know, like when people get married, they form a union, right? The United States Union, right? United States of America, it's a union, it's a joining up of all of it, okay? That's all the U is representing for us, is it's a union. Okay, so what if this had said and in between? What if instead of saying or, it said and? X is less than 2 and x is greater than 2. Would it? No, but you're getting close. What would happen if it said and in between?
It'd be both and.
That's, who did you say that to, Zane? Say that louder.
It wouldn't be.
It wouldn't be anything. There are no numbers that are both greater than 2 and less than 2. Correct?
Yeah.
Okay. Well, actually, the way we just said it, you would include 2, wouldn't you? Greater than 2. Well, if it said equal to. If it said greater than or equal to, it would include 2, but it doesn't have an equals to on that one. Andrea?
Like 1 point, or, never mind, you're right.
Even fractions wouldn't work, right? Fractions, decimals, they fail. But I'm glad that you're thinking, like, I don't have to just use integers, because that's a common way to think, is that I just need whole numbers there, and you don't. Fractions, integers, all that stuff, everything would be a possibility to consider. But there are no numbers that are both less than 2 and greater than 2. If it had the equal to, we would include 2, but it doesn't. So the and the or, those matter. It matters which one you're looking at. All right, one other part of this lesson today is to talk about absolute values. The absolute values relate to what we just did, and there's a reason that we kind of did them in the order we did. So let's take a look. This actually says the absolute value is greater than k. And when we looked at absolute values before, we didn't go super far in depth in this, but we did talk about the fact that they're distances, right? It's a distance, so it's always a positive quantity. If I want my distance here to be greater than a value, think about a number line. Here's my number line. I am going to include the number 0 because when we talk about absolute values, we're talking about distance back to 0. And if I have a distance that's k away on both sides, right here, and I want the distance to be greater than k away, if I am further away than k, then that means I would need to be shading on the outsides. Those are all of the values that are further away than k. So this interval would look like this, or this graph would look like this. It's shading on the outside of the graph. And it says greater than without the line, so we're using the parentheses as well. Imagine, this is exactly what we kind of have done. When my husband was looking for full-time pastorate positions, I am going to continue to teach at OBU. I believe this is where I'm called to be. Okay? So what we did is we said, OBU is our central location. And we did it in a two-dimensional plane, not just in a one-dimensional number line. But this is what we did. We said, I'm not willing to go any further, and I did it by drive time, not miles, but any further than driving X amount of minutes per day. So we did. If you imagine like putting like your stake in the middle of I-40 or something like that, and you went down the number line this way, and you said, okay, this endpoint and this endpoint can't go anywhere beyond that. Those points on the outsides are untouchables. I'm not willing. I'm not able, whatever. Okay? That's what we're looking at. These areas on the outside in this case would have been the no man's zone for me. Now, likewise, on the second one, if it says less than k, it would mean I would shade on the inner part. I need my values, my distances, to be closer to the origin or to 0 than k. So here's my distance, k on both sides. And notice, if I'm going k to the left, that would be negative k, right? This is negative k over here. But my shading is less than k. My distance has to be between them. This would be the area in which I was willing for us to actually move to live in, to drive from. Oh, mine was brackets. Again, this is what happens when I keep zooming in and out. Thank you so much. Yes, this one had brackets because it has less than or equal to. Thank you.
I have a question.
Yes, ma'am.
Why do you put K's on both sides?
Because it's representing a distance. If this said 5, my distance would be 5 to the right, which would put me at 5. It'd be 5 to the left, which would put me at negative 5. This negative k right here is actually the value. This is a distance. I'm just marking the distance away.
Why is it K and not X?
X is representing the values that satisfy.
Oh, yeah.
K is representing the furthest away I can go.
Okay.
Yes. Okay, so let's do an example how these work out. The whole idea is that we are looking at values that are either further out or inside. So before I can do that, I want to relate this back to the last two problems we did. Notice this graph, the first one. It looks like this one over here that had the word what in between it? Or. This graph is saying that my x value, which I'll write over here, needs to be less than negative k or greater than k. It's an or statement. The one on the bottom says that my value needs to be between the two. It's an and statement. So I can do one of two things. I can either write x is greater than negative k and x is less than k, and that's fine. I can write that. It's totally true, completely accurate. Another possibility is that I could write this as what I call a triple inequality. These are greater than or equal to, sorry. This bottom one is the way that I prefer to write it. It looks like it's sandwiched in between, just like the graph looks like. I start with negative k, I end with positive k, and x is sandwiched in between. If you prefer to write it with the and notation, that's fine too. Doesn't hurt anything. One word of caution about this, though. not caution, but one word of sort of helping you to remember is I remember it like this. I like mnemonic devices. You see this symbol and this symbol? This is a less than. I didn't write that. It was greater than to start with. Sorry. Let's move backwards. All right, there we go. Great or symbol. And this one is a less than and symbol. So I remember this as a mnemonic device. Greater ends in or. And I know it's not quite true, but we can pretend, right? Phonetically it does, right? Phonetically it does. And less than ends in and. Again, not really, but it's close. Greater and less than. Okay, so that's how I think about it. That's the mnemonic device I use. Like for real, that's what I use. Not just like I'm telling you that you should do this and I really do it that way, okay? So let's take a look at a couple of examples and then we'll be done for today. This symbol says what? Greater or less than? Greater. So this is an or statement. So what does that mean? Well, it means that I'm going to have two inequalities. One of the inequalities looks exactly like the one that I started with, without the absolute values. And the word or comes next. The other inequality looks like what I started with the symbol reversed. Okay, so the less than is a greater than, or the greater than is a less than, excuse me. And the value is opposite, -5.
So if we break it up into two, we get rid of the absolute
When you break it up into the two, you get rid of the absolute values. And if you take a look, that's exactly what we did here, right? There's no more absolute values. That's where that's coming from. And we're in this case where it says greater. So you notice one of the values, x greater than k, looks exactly like this did, x greater than k, but without the absolute values. The other one looks like we took the inequality and we switched it, and we made the k negative. So over here, I've got two inequalities that I can solve now. Very similar inequalities, in fact, right? Can subtract my 3. So I have -2x greater than or equal to 2. Divide by -2, and I have to remember what? Flip my inequality. So this will now be a less than or equal to. And 2 divided by -2 is -1. The second one, same steps. Subtract 3. -2x less than or equal to -8 in this case. Divide by -2, I have to remember 2. Flip my inequality. So now this one's a greater than or equal inequality. And -8 divided by -2 is 4. These have a word or between them, correct? So on a number line, those are the two values I need. I need a -1 and I need a +4. And because it's an or statement, where is this going to be shaded? On the out-hand side. I mean, it has to be shaded toward the outsides. If you weren't for sure and you wanted to analyze it more carefully, remember what we do is we look at each one of them. This says less than or equal to -1. That's on the left. This says greater than or equal to 4. That's on the right. I'll draw my arrows in each of those directions. And then do I use brackets or parentheses on this? Brackets. And then my interval notation for this would be -∞ to -1, bracket. Always put a union, u, in between. And then 4 to infinity. Can you guys give me one more minute to finish the other problem? We'll do it fast. This is my, and if you need to go back and look at it again, that's fine. This is one of those ones that I told you you could write a triple inequality, and I haven't shown you what that actually looks like. This triple inequality is going to have one part of it that looks exactly like this already looks. 6 minus 4x less than 2, just no absolute values. And then before it, I'm going to put the other symbol with a -2. This is the triple inequality. It's always the same symbol, going in the same direction. Don't go flipping signs around here, okay? Same direction. And it's the same number with the opposite part of it, so -2. Now, when we solve this, the 6 has to move first, just like it would if I had a regular inequality. But I do it to all 3 sides because there are 3 sides. It's a balancing thing, right? So negative 2 minus 6 is negative 8. In the middle, I have the negative 4x. And 2 minus 6 would be negative 4 on the right. The goal is to get x alone. So I'm going to do the same thing. I'm going to divide by negative 4 to all 3 sides. Okay, negative 8 divided by negative 4 is 2. In the middle, I have x. And then negative 4 divided by negative 4 is 1. But I divided by a negative, which means I need to flip both signs. So these signs are now both greater than signs. But it should make sense. You should be able to read this from left to right and it makes sense. Is 2 greater than 1? Yes. That makes sense. It has to make sense or you've done something wrong. So on a number line, whoops, give me a line. On a number line, we've got the 1 and the 2. Make sure you put them in the right place. It will look backwards from what we've just written, right? But 1 comes before 2. And I need the values between them, right? So my shading is between them. And will I be using parentheses or brackets on this particular problem? Parentheses. Opening toward the shading, which is in between. And then my interval is 1 to 2. Again, looking like, almost like it would be an ordered pair.